Hello everyone, welcome to lesson 2. This one we're going to continue solving equations, but now we're going to look at two variable systems. So lesson 1 was only just one variable, one equation. Now we're going to look at systems of equations, and you're going to have two variables and two equations to solve. Now the method that you do for this, or there's two methods that you're allowed to use: substitution and elimination, and I'll show you a couple examples of each. Plus I'll give you kind of a tip of when to use one. You'll actually need to know how to do both, because depending on the type of question, one method may be significantly easier than a second method. What I am going to give you some advice on is that these take quite a bit of space on your paper. Do not try to condense this or try to do too many steps in your head, because if you make one little mistake somewhere in this long process, the whole equation is wrong. So you have to be very careful, and you have to do a lot of checking your work as you go through, and be very careful of your signs, because one little mistake makes everything wrong. So what we're going to do is kind of basically, when I use the substitution method in the first two examples, I'm going to solve or rearrange one equation for a variable, and I'm going to look for the easiest variable to manipulate for. Then I'm going to take equation 1 and sub it into equation 2. What I'm basically trying to do is take two equations, reduce it to a single equation, solve that, because I just finished doing that in lesson 1, and then go solve for my other variable, which you'll see in our first two examples. So I'm going to use the substitution method first. With examples number 1 and 2. And example 1, we're going to look at our first equation, and I tend to number my equations so that I don't get lost. X plus 7y equals 1. Equation 2, 3x minus 14y equals -7. Now, this requires a little bit of planning on your part before you just jump right in. What you should be looking for is equations that have one of your variables in one of your equations to have a coefficient of 1. That's the easiest thing to manipulate for, because all you got to do is just move the other term to the other side, and it's already isolated. You have to do any divide by. It's only a single step to manipulate that. So the easiest way to do this question, hopefully you look at equation 1 and say solving equation 1 for x is the easiest step that I can do. Always look for the easiest route. So I'm going to, off to the side here, write equation 1 as x equal to 1 minus 7y. When I take the 7y to the other side, it becomes negative. Now, the process of this, and the reason why you can't solve this system, is because there's two unknowns and two equations. It's a general rule that for every time you have an unknown, you have to have an equal number of equations. In this course, we're going to either solve one or two variables. Well, what you actually do in Pure Math 20 and linear algebra and university level math is you would solve 3 and 4 variable equations. And you would need 3 equations for 3 unknowns, 4 equations for 4 unknowns. It just gets really messy. The process is identical to working with 2, so that's all we're going to do to prepare you for 30 Pure. So what I'm going to do with the substitution method is I'm going to take equation 1 and sub it into equation 2. And what this does is it makes equation 2 one equation with one unknown. Instead of writing x, I'm going to write 1 minus 7y minus 14y equal to -7. Notice when you look at equation 2, there's only one variable there. That's something we've just finished working on, solving equations with one variable. Yeah, I'll expand, I'll collect like terms, but I can solve that. I can solve that for y. So I'll expand this, 3 times 1 to give me 3, 3 times negative 7 to give me minus 21y, minus 14y, equal to negative 7. Collect like terms, I end up with 3 minus 35y equal to negative 7. Move the 3 to the other side, end up with negative 35y equal to negative 10. Divide by negative 35, y equals 10 over 35. But this can be reduced. We can divide by 5, so it can be written as 2 over 7. Now that you know what y is, go back to equation 1. X is 1 minus 7y. So if you know what y is, you should be able to find x. So x will be equal to 1 minus 7 times 2 over 7. Again, we're working with fractions. So 7 times 2 is 14. Divided by 7 is 2. 1 minus 2, x equals negative 1. Now, what you should be able to do is you should be able to plug negative 1 for x into equation 1 or equation 2 and 2/7 into equation 1 or equation 2, and you should be able to prove left side equals right side. And I'm going to do that on another slide for it. We'll do a quick check to verify that this is the solution. If only one of them works, then you didn't find the right answer. These two answers for x and y should work in both equations. If they don't work in both equations, you didn't find the right answer. So just to recap before I do my check, with substitution, you look for the easiest equation to manipulate for a variable. And by that I'm saying look for something that has a coefficient of 1 or negative 1 on a variable. Solve for it. Plug that equation into the other equation, solve for the one unknown, put it back into the original, solve for the other unknown, check your solution. So let's do that on the next slide here. Equation 1, in our check, we have x equal to negative 1 and y equal to 2/7. Equation 1 was x plus 7y equal to 1. So let's do our 2-column check. So it'll be negative 1 plus 7 times 2/7. Well, we get negative 1. 7 times gives you 14 over 7, which is 2. Negative 1 plus 2. 1 equals 1. Left side equals right side. So it checks in equation 1, but that doesn't mean it's perfect until you check it in equation 2. Equation 2 is 3x minus 14y equal to negative 7. Again, do the 2-column proof. 3 times negative 1 minus 14 times 2 over 7 has got to work out to be negative 7. Well, 3 times negative 1 is negative 3. 14 times 2 is 28 divided by 7, so we end up with minus 4. Negative 3 minus 4, negative 7 equals negative 7. Now we know the solution is x equals negative 1, y equals 2/7. A lot of times it's written as a coordinate, so you may see it written as a coordinate because if you were to plot these lines, which we'll do some graphing in one of our later units, you will see that the point of intersection is going to be the solution to the two equations, and that's going to be written as a coordinate. So these represent two lines. Where these two lines cross is the solution. So you may also see these written as a coordinate in alphabetical order, x then y. So there's example number 1. Let's do another example with substitution. So this system, I'm going to have equation 1, which will be 2x minus 3y equal to 5. Equation 2, 1/2 x minus y equal to 1. Now, if you don't want to work with fractions, you could change 1/2 into 0.5 very easily if you wanted to. But 1/2 is a pretty basic fraction. It's not that hard to work with, so I'm going to leave this as 1/2 x. Again, look for the variable that's the easiest to manipulate in this system. Y in equation 2 is the easiest one to manipulate. I'm going to move the y to the other side and move to 1 to the other side. So equation 2 will look like 1/2 x minus 1 equal to y. Now I've also could have moved the 1/2 x to the other side and divided by -1. Would have gave me the same result. I just always make my variable that I'm isolating first positive and move everything else to the opposite side. I just like working with positive variables. So I moved y one way, I moved the 1 to the other. In this case, I'm now going to substitute equation 2 into equation 1. And equation 1 now looks like this. 2x minus 3, and for y, I'm going to plug in 1/2 x minus 1 equal to 5. Going to expand this out. Notice I'm now down to one variable, so I'm going to expand it and simplify it and solve for x. So I'm left here with 2x minus 3 times 1/2 gives me minus 3/2 x. Negative 3 times -1 gives me positive 3 equal to 5. Now I have a couple options to work with here. If you don't want to work with fractions, then you could multiply out the fraction, and since I've been pushing that on you in lesson 1, I would suggest to continue doing that in lesson 2. Eliminate the fractions. Multiply everything by 2. Now the only thing I'm going to do first, before I multiply by 2, is I'm going to move the 3 to the other side. So I'll leave this as 3/2 x, but I'm going to write this as 5 minus 3 to equal 2. Now I'm going to eliminate my fraction by multiplying everything by 2. 2 times 2x is 4x. Again, I'm not going to show this step in between now. 2 times 3 is going to give me 6. Divided by 2 will be minus 3x. And 2 times 2 equals 4. The most common mistake that I see students make when they multiply by the lowest common denominator is they either forget to do a term or they just make a mistake in their multiplication. A lot of times I'll see students just multiply it to the first term and to the second term, but forget the term on the other side of the equal sign. So make sure you multiply it to all three terms and simplify. Now try to simplify as you go. 4x minus 3x is x equal to 4. Well, that's simplified really quick. go to equation 2, we now have 1/2 times x, which is 4, minus 1 equal to y. Well, half of 4 is 2. 2 minus 1 equals y. Y equals 1. I'm not going to check this one. I can leave that one for you. Again, if you were to check, you would have to plug 4 and 1 in for x and y into both equations and prove left side equals right side. You could almost mentally check these ones because they are whole numbers. You could probably do this in your head by doing a quick check just to make sure that left side equals right side. So there's 2 examples involving substitution. Notice the reason why I chose substitution is I had one of my variables with a coefficient of plus or minus 1. You'll notice in the next 2 examples that case doesn't happen, and I will choose a different method. But with substitution, the key is I've got 2 variables, 2 unknowns, so I got to manipulate one equation for one variable, plug it into the other equation so that it's in terms of one variable, solve it using my previous methods from lesson 1, then plug my answer back into one of the originals and solve for the other variable. Now with elimination, this is another method. With elimination, what you're going to do is you're going to basically try to eliminate a variable. And what you can do with equations, just like you can add or subtract to an equation, you can take entire equations and add entire equations. Or you can subtract entire equations from entire equations. Again, as long as you do the same thing to both sides, you are not breaking any rules. So you'll notice in my steps, figure out the very first thing is what's the easiest variable to eliminate. Step 2 can be 1 or 2 parts. You're either going to add equations to eliminate a variable or even use a combination of multiplication with addition and subtraction to eliminate a variable, which you'll see in my examples. Then you'll create a new equation, solve that for one variable, and plug her back in to find the other variable. And the tip is, with elimination, you will see more complicated types of equations. You will see equations that do not have variables of plus or minus 1. And with this, elimination is generally faster, so that you don't have to work with rational equations. You can use elimination to save yourself a little bit of work. So example number 3. We're going to use a process called elimination in this case. And here's our system. Equation 1 is 6y minus 5x equal to -7. Equation 2, 2y minus 5x equal to -19. So there's our 2 equations. The very first thing that you have to figure out is what's the easiest variable to eliminate. And by that, I mean to get to add or subtract to 0. Well, if I subtract the y's, I do not get 0. If I add the y's, I do not get 0. But since the coefficient of x is the same in both equations, I should be able to either add or subtract to make it 0. Well, if they have the same sign, then what you're going to do is you're going to subtract the equations. If they have opposite signs, you would add the equations. What your goal is to do an operation to eliminate a variable. So in this case, I'm going to subtract the equations. And as long as I subtract the left sides and the right sides, I haven't changed the system. So 6y minus 2y will give me 4y. Negative 5x minus a negative 5x means plus 5x. This should eliminate to give me 0. That was the goal. On the other side of the equation, I get negative 7 minus 19. So it's negative 7 minus a negative 19 will basically be 19 minus 7. So you should end up with positive 12. Now what you've created in this by doing the operation is a new equation. So I usually give it the number 3. I've eliminated a variable from my original 2 to leave me with a new equation, 4y equals 12. Divide by 4, y equals 3. Go back to any one of the originals, doesn't matter which one. I'm going to go with equation 1. 6y minus 5x equals negative 7. Plug 3 in for y. 6 times 3 minus 5x equals negative 7. 18 minus 5x equals negative 7. Again, I'm going to move the 5x to the other side, so it becomes positive. 18 plus 7 to give me 25. Divide by 5, x equals 5. Again, you can do a very quick check, which I'll do on the right here. We have x equal to 5, y equal to 3, equation 1, 6y minus 5x equals negative 7. Quick substitution, 6 times 3 minus 5 times 5, 18 minus 25, negative 7 equals negative 7. Perfect. Go to equation 2, 2y minus 5x equals negative 19. Again, plug in x and y, so you get 2 times 3 minus 5 times 5, so you get 6 minus 25, negative 19 equals negative 19. I can get this all done on one slide. The solution is, I'm going to write it as a coordinate 5 and 3. Now this is one of the easier types of elimination because we already had the variables with the same coefficient. You'll see in my next case we'll have to do a few steps to get that to happen, but once you get the variables to be the same coefficient depending on the sign, you'll either add or subtract the equations to eliminate a variable. No matter what method you choose, elimination or substitution, the goal is to get down to a single equation with one unknown. Solve it, plug it back into one of the originals, find the other variable. You can see with the multiple step type problems that one little mistake in signs can be very frustrating when you're going through these. So you need to take your time. It's not a race when you're dealing with systems of equations. One mistake can make or cause a lot of problems with your questions. Now I'll give you one of the worst case scenario types you'll see in example 4. Example 4, again, we'll use elimination. But we can use this method for particularly difficult equations. And here's the system. So we have 5 times x plus 2 over 6 plus y plus 8 over 9 equal to 6. There's equation 1. Equation 2 will be 2x plus 1 over 3 minus 5y over 4 equal to 7 over 4. Now this would be worst case scenario for this course. If you can solve this type of system, you could do any kind of question. Now what we're going to do is you're looking at this and going, whoa, that's a big mess. First of all, we have some fractions. Well, we already know what to do with the fractions. Let's get rid of them. After that, let's simplify and get this down to a simpler system of 2 equations, 2 unknowns. Then we'll look to see how we can try to eliminate the variables. So what I'm going to do with equation 1 is get rid of the fractions, first of all by multiplying by the lowest common denominator. Now the number that both 6 and 9 go into, the lowest one, is 18. When I look at equation 2, the lowest common denominator for equation 2 that 3 and 4 go into is 12. So to start, I'm going to try and simplify this system. Now equation 1 is going to be 18 times the top divided by 6. Well, I'm going to reduce right away. 18 divided by 6 will be 3. Times the top, well, 3 times 5 gives me 15 times x plus 2. Now again, if you don't see this, write the whole thing out, then reduce after. But 18 divided by 6 gives me 3. Multiply by the top, 3 times 5 is 15, and I'll multiply it by x plus 2. My second term, 18 divided by 9 is 2, times the numerator, which is y plus 8, and 18 times 6, I'm going to punch it in my calculator just to make sure I'm right, is 108. Do the same thing with the other side, or the other equation. Actually, let's just simplify equation 1 first, and then we'll look at equation 2 after. Again, still not quite there, but if we expand 15 times x to give us 15x, plus 30, plus 2y, plus 16, equals 108. Keep simplifying. 15x plus 2y, 30 and 16 to give me 46, equals 108. And I'm going to go even one step further. Might as well take the 46 to the other side and write this as 15x plus 2y. 108 minus 46 should give me 62. There's equation 1, simplified. I'm going to do equation 2 on the right. Again, multiply by 12, so 12 divided by 3 will give me 4 times the top, which is 2x plus 1. 12 divided by 4 will give me 3 times the top, 5y, and I'm going to be equal to, again, 12 divided by 4, which will be 3 times 7. And again, if you can't do that division and simplifying in your head, write out 12 times every single term, then reduce. You will eventually get down to what I have written here. Expand it. 4 times 2x gives you 8x plus 4 minus 15y equal to 21. 8x minus 15y, 21 minus 4 should give us 17. Alright, that was a lot of work just to get to a point where we now have a simpler system. All I've done now is just rewrote those two nasty equations into two simpler equations. Then I'm going to look at those two simpler equations and try to come up with a system here. So let's take equation 1 and equation 2, and we'll write it on another slide, and then we'll go and look at trying to use elimination to solve. Haven't even started the system yet. All I've done is taken those nasty fraction equations, wrote them in a different form. So equation 1 becomes 15x plus 2y, forgot what it was equal to 62. Equation 2 becomes 8x minus 15y equals 17. 8x minus 15y equals 17. And now you're saying to yourself, well, I don't have any coefficients of 1 or negative 1, and neither one of these have the same coefficients, so I just can't add or subtract. So here's what I need to do. I need to multiply to both sides of an equation to make variables the same coefficient in both. Now when I look at 15 and 8, to finally have a number that they both equal to each other will be a very big number. But both 2 and 15 can very easily be turned into 30. And to do that, I could take equation 1 and multiply it by 15. I could take equation 2 and multiply it by 2. And again, as long as I do the same thing to both sides, I can basically do whatever I want to the equation. I can't eliminate at this stage yet. Not until they have the same coefficient. Then I can add or subtract. So I'm going to make the y's equal to 30 so that I can either add or subtract these equations to eliminate it. I could have worked with the x's, but the number that both 8 and 15 go into is a lot bigger than 30. 15 and 2 both go into 30. So multiply equation 1 by 15. So 15 times 15 gives us 225x. 15 times 2 is 30y. And 15 times 62, now these are pretty big numbers. That's okay, we have a calculator. 930. Equation 2 becomes 2 times 8x, which is 16x. 2 times 15, y, to give me negative 30y. And 2 times 17 will give me 34. Now I'm finally at the stage where I can use elimination. All of that previous work was just a matter of simplifying and writing them as equivalent equations with the same coefficient. Now I can see a plus 30 and a minus 30. If I add these equations, I'll create equation 3. 225 plus 16 will give me 241x. Positive 30 and negative 30, again, eliminates the y. And 930 plus 34 will give me 964. So if you go 964 divided by 241, you end up with x finally equal to 4. Plug that into one of your simplified equations. Go back to equation 1. 15 times x plus 2y is going to equal to 62. 15 times 4 plus 2y equals 62. 60 plus 2y equals 62. Move the 60 to the other side. 62 minus 60 gives you 2y equal to 2. Y equals 1. The solution is 4 and 1. So that's the worst case scenario. One where you'll have to do a lot of work just to write your equations in simplest form by clearing fractions, expanding, and collecting like terms. Then the second case would be you also have to multiply one or both of your equations to create a coefficient on one of your variables to be the same, so that you can add it or subtract it to make it 0. What we did on this slide is just the elimination part. We finally made the equations with the same coefficient, then we could add or subtract and solved. What we did on the previous slide was just a matter of writing the equations in simpler form, expanding and collecting like terms. We've done lots of that already in Unit 1 and the beginning of Lesson 1 in Unit 2. Work on exercises 2.2. Practice your substitution and elimination.